In the next section, we will be talking about arcs and central angles of circles. So first we're going to go through a few different facts about circles. The first fact is that the diameter of a circle divides our circle into two semicircles. To label a semicircle, I'm going to put some points on this circle. We have point A, well, this point C, and B. We'll call our center point O, and point D will go over here. Okay, so a semicircle, an important thing to remember about a semicircle is that it's equal to 180 degrees. So our full circle is 360, half a circle is 180. And then if we wanted to label or to write semicircle ACB, we would write that as ACB with an arc over the top. To label a semicircle, we need to use 3 points on our circle. So we could have semicircle ACB, or the other one would be semicircle ADB with the arc over the top. Okay, remember, similar to labeling other lines, if we had a line AB, that's a straight line over the top. Now if we have an arc or a semicircle, we have to make sure this line above looks like an arc instead of a straight line. Okay? Our second fact is that a minor arc minor arcs are shorter than semicircles. So that means that they are less than 180 degrees. So if we were looking for a minor arc on this circle, minor arcs you're going to use 2 letters to name. So one example could be arc AC with an arc over the top. Or we could have arc CB. And we can keep going. See, we have BD or AD. Okay, and there are more arcs that you could label, but these are some examples. A minor arc is less than 180 degrees. A major arc is longer than semicircles, so that means it is more than 180 degrees. And for major arcs, we are going to, again, use 3 letters to name. And the reason we use 3 letters is because if we were talking about major arc CBD, and we tried to name that as CD, that's not telling you if you're looking at the bigger part of the circle or the smaller part. So major arcs always use 3 letters. If it is greater than 180 degrees, you have to have 3 letters in the middle there. So another example of a major arc, we could have BDC. And I'm going to just move this point D over a little bit, just so you can see more that it is a major arc. It's not a straight line across that other way. CDB right here is our major arc that we're talking about. Okay, so I'll erase that line. For the rest of them, we can name the rest of our arcs. we have DCB as another example, ACD, or CBA. Those are all examples of major arcs that are equal to greater than 180 degrees. We got our last two facts down here. The total degree measure of a circle is 360 degrees. We talked about that one already. And the degree measure of a semicircle is 180 degrees. Yeah, we talked about that one already up top. 360 for a whole circle, 180 for half a circle. Okay, so let's look at some examples next. Let's see, for circle O, that means point O is in the middle. The measure of arc YX is 110 degrees. Find each measure. So we got our points on here. This is Y, X, and Z. So it told me YX right here is 110 degrees. Find each measure. So XY, it told us that one already, is 110. And we have to draw our arc symbols on here. So those are hard to type on a computer, so just draw those in. Now, the next piece we want to find is XYZ. So if we look, XYZ is this whole semicircle. And remember, a semicircle is always equal to 180 degrees. I know that's a semicircle because it has a diameter, a straight line going through the center, starting at X and ending at Z. The measure of angle YZX, we have YZX is right here. Now, we know that YX is 110 degrees, and our whole circle is 360. We can take that 360 minus 110, and that's going to leave us with YZX. So when we do that, we get 250, and that is our measure of arc YZX. And then our last piece is the measure of arc YZ, which is right here. Well, since we know that ZYX is 180 and YX is 110, we take off that piece, that 110 piece, we are left with YZ, which gives us 70. Okay? Okay, for our next one here, it says, for any circle, the measure of an arc formed by a central angle, one of its vertex at the center, is congruent. Hard to put that word in there, but it's congruent to the angle itself. So let's look at a picture here. If we have point A right here, B, and O. What this is saying above is that this arc right here, arc AB, is going to be equal to this angle right here, since O is at the center. So if we are given that the measure of angle AOB is 30 degrees, this is our given information right here, 30, then we know that the measure of arc AB is also going to equal 30 degrees. So this arc out here is also 30 degrees. Okay, so let's look at some more examples. So for this example, if we're given this information here, it says find each indicated measure below. So if we have the measure of angle DOC right here, this is DOC. Well, if we know this angle is 120, we have a pair of vertical angles straight across from each other. That makes DOC also 120. The measure of angle 2, we have a diameter going straight through our center right across here. Our diameter divides it into two semicircles, so half that circle is 180 degrees. If we took away this angle right here, which we know was 120, if we take that angle away, we are going to be left with angle 2 here. So 180 minus 120 gives us 60. That makes angle 2 60 degrees. And then if we know this is 60, we can do the same thing we did earlier, vertical angles straight across from each other. Angle 1 is also 60 degrees. Now it's asking for the measure of arc DC. Arc DC is right out here, and we just learned that the angle at the center is going to be the same as the angle of the arc. So if this angle inside is 120, this arc is going to be 120 degrees. Okay, so then if we have arc DAB, DAB is right here. If we look, that is a semicircle. And we know a semicircle is 180 degrees. The measure of arc AB, just this piece right here, we know the inside is 120. AOB is 120, so that means AB is also 120. Arc DAC. So if we go from D to A all the way to C, that is everything except this piece right here. If we know that DC is 120, our whole circle we start at 360 degrees. We're taking away this part right here, which is 120. It's going to give us DAC, that rest of our circle. So 360 minus 120 leaves us with 240. And then our last one asks for BC. BC is this piece right here from point B to point C. We know that the inside, angle 2, was 60 degrees. That makes our arc 60 degrees as well. Okay, let's do one more quick one. If this is our given information on our circle, if we look at the measure of angle ROS right here, if our arc is 50 degrees, we know that the inside is going to be the same, 50 degrees. Arc ST is the rest of that semicircle. So if we know a semicircle is 180, and we take away this piece right here that is 50, we are going to be left with 130 degrees for ST. Similar thing with PT, we have this piece is what we're looking for, and we know that this piece is 70. We start with the semicircle and take away 70, we are left with 110. Okay, SP. SP goes from here over to P. We know that SR is 50 and RP is 70. SP is that whole thing. We add 50 plus 70, we get 120. Then we have RST. RST is this whole semicircle. That's an easy one. Semicircles are already always 180. And then our last one, PRT. PR all the way over to T. So that means we want everything except for this piece right here. So if we figure out what this piece right here is, PT, we already know that's 110 from above. So if we start with the whole circle, 360, and we want to take off that 110, we are left with 250 degrees.